Coming.
Is the party, Miss Wilson?
There is?
Yeah.
Well,
Don't be late, Miss Wilson.
I'm sorry, but I have not had a break all day except for lunch, and
Where's Miss Wilson? Where's that?
no,
We're here?
I might not be. This may be my last day.
What? No, Miss Wilson. No. No. You can't. Leave next year.
No?
Leave after APs.
I'm gonna go home and relax.
After APs.
Today?
Miss Wilson, get your half a cup of wine and relax. Take like a week off. Take a week off, Miss Wilson. A week off. You'll be able to recover from the hangover after a week. Take a week off. I don't think anyone will notice. You'll be sick. And by sick you mean hungover.
They would, because then there'd be no real profit for the second time this week.
Oh, you got that too? It's a lot of profit.
Then we had a meeting this morning.
They were like venting over the announcements today about it. They're like, teachers you have to come in 2 days. This is so unprepared.
Have the meeting in the morning until the bell, then we have class. And then at the bell, I have to run the 222 Proctor exam. And then at the bell, I gotta run back up here and try and get all my Zooms and everything going. I'm like, they don't even give us, they're supposed to like, well, you're a subject. I know, imagine.
Whoa.
Hey, look at that. Teacher, sound bell, please close your doors. Any students caught outside, please report to the auditorium. Any students caught outside the bell, please report to the auditorium. Teacher, the sound of the bell, please close your doors.
I hope the
It's
online
already sweet.
Online kids lock them out of the Zoom, go to the Zoom auditorium.
go to the Zoom auditorium, please.
Purgatory, Zoom
Whoop.
purgatory. That's where they're all gonna go. I'm gonna go. Freezing.
Today is Tuesday.
Oh, there's a little beta meeting.
Today is
There
Tuesday,
was.
I forgot.
the 29th day of September.
But you got your Microsoft points, so good job.
Middle.
Now I just gotta find $40 for it.
I'm sure it's like around somewhere. Like
Sure,
around
yeah.
school, like you find a little quarter, find another. Eventually you'll find enough quarters around the school.
Yeah, exactly. Eventually I will.
We'll only be accepting all those quarters in quarter form though.
I think we all the same would accept quarter
Okay.
for Lars we'd accept it.
I really like it.
All right, so
Oh, okay.
let me join in on my iPad and get that going. And I'm going to put 2 bell works up for you, some prior AP questions. How's everybody online doing? Okay? We doing all right?
Yeah, sure. It's okay.
Good.
Are we doing okay with our homework?
Yeah, I didn't completely understand number 3, and I don't know if I did number 4 the way they wanted me to do it, but I did
Look
it.
at them. We can go.
You mean 14, right, Lauren?
Or yeah, 3 and 14, the first problem and the very last one.
3.
Yeah, if we can go over 3 and 14.
I love 14.
Okay.
It was the best problem I've done in a while.
What problem?
Number 14.
Oh, isn't that a cool
That was a
problem?
great problem, Miss Wilson, except you have to assume the wall has no depth. Like,
Yeah.
that's one thing, and you have to assume the rope is tense. Like it's
And there's no
tension,
friction either.
And then no
Right,
friction exists.
Yeah,
There are a few
that's what
assumptions you have to
physics
make.
class is for.
Yeah.
This is the pure mathematical aspect of it.
Air resistance.
But yeah, when you don't have a great teacher, it's hard to learn it.
When you don't have a great
Stop
teacher,
complaining, this is calculus.
are you calling me not a great teacher?
No, I'm talking about physics.
Physics.
I dropped out of physics and picked up weight training because I said I'm not doing Mr. Turner.
Miss Wilson, you're a great teacher.
He's a nice
Astronomy and
guy.
guys, astronomy and
Mr. Turner's nice, yeah, but
Well,
He was a nice.
he's probably too professorial or something. I don't know.
Yeah.
I wouldn't even really say that. He's just kind of boring.
All right, well, anyway, I'm gonna take attendance. You guys try and answer these two AP Calculus BC questions. BC, these are actual, from 1997. I think they're both from 1997, I forgot.
Wow, they're older than me.
Yeah, most things probably are. So anyway, I'm gonna take attendance while you guys try and answer those, and I'll get right back with you in a second. So Amag is here. Lauren's here. Where is Pranay? Is Pranay not here? Oops, sorry. Oh yeah, I have 3. Can you guys see? Can you see that, Estella? It's probably as big as I can kind of make it. Will is here. William Maguire. Okay. Zach is here. Sarah Johnson is absent. Lars is here. Zara is here. Yaseth is here. Andrew is here. Caleb's here. Stella's here. Gary Nicola's here. Where is Isaac? Isaac's here. Sydney is not here. Okay, so I think my attendance is good. Hey, you guys done?
Not quite. Not with the second one anyway.
Why not? I'm kidding.
I'm just not as fast as you, I guess.
Did you guys get an answer for A? Okay, I'll wait. I think number 1 might be kind of hard for you guys. I'm not sure. Maybe it's too much too soon. Anybody get an answer for 1 yet?
I did, but I'm not exactly sure if it's right.
What'd you get?
I got E. I don't really think it's right though.
Got E as well.
Why did you get E?
I just put the y. I took the derivative of the what y equals and put it on the top, and then I took the derivative of x and put that on the bottom.
Clever. Clever. X is 4 minus 12x squared minus 3. Oh, that's x squared. So. Anybody get an answer for number 2?
I got A, I think.
A. Zach, did you get number 2?
Not yet. I was sort of figuring out number 1 still. I just finished off.
You guys are so slow.
I'm starting to know the
That's it. I'm gonna quit. I'm gonna quit.
I agree with Isaac on A for number 2.
With A on number 2. Okay.
Yeah. I was a bit slower.
Mm-hmm. Anybody else have a different answer for number 2, or we haven't gotten there yet, or we're not sure?
Taking our way there.
Actually, let me do it. B minus 1 plus 1.
I got A as well for number 2.
You did. So we've got 3 A's for number 2. Do we still only have 2 answers for number 1, namely E?
I got E.
Good.
I got E.
Excellent. Yeah, I'm just seeing if a 0 is a negative, if it's a 2 is a positive, and if it's a negative 2 is a positive, so positive. 4, 5, so positive. On, relative maximum. Yeah. So A is correct for number 2. I read it wrong. I read it as a relative minimum. I was like, it's at 1, not -1, but it's right. So A is 1. Sorry. Number 1 is E. Number 2 is A. Now one more for me. Just one more. And this one is, I think this is an A-B question. This is an A-B question. But remember, you'll have A-B questions on your exam. And since you just learned about this, I thought it was a nice tie-in. Anybody have an answer yet? Lars, what's the answer? E, okay. Anybody else have the same answer or a different answer or? What's the date today? The 29th. Wow. Anybody else have a different answer?
What did Lars say? Did he say D or E?
He said E, right, Lars?
Yeah.
Is it E?
I'm gonna say B.
Okay.
Zach says B as in boy. Lars says E as in Edward.
And I'm thinking C, so.
E as in Charles.
We only need an A and a D.
We need
Yeah, I'm thinking C too.
I think we all agree that 2 is true, right? At
Right.
least.
Mhm.
Yeah, we all agree.
Yeah, but differentiability implies continuity, so
Yeah, that's the thing.
Right.
yeah, so then
But what if
Yeah,
it's
I
like
don't
a
think-
cusp?
Mm.
Oh, it could be.
Wait. Would it be differentiable if that's the case?
If there was a
If you're
cusp.
using.
Well, I can tell you one thing. So listen, this says this is the derivative at x equals to 2, right? And it's 5. So it's differentiable at that point, right? Therefore, f is continuous because if it's not continuous, we can't find the derivative, right? It's also differentiable because they differentiated and gave us that the derivative is 5. So the slope of the tangent line is 5. So those two are okay. But where have you heard that the derivative of a function is continuous at x is equal to 2? The derivative of the function, not the function is continuous, but the derivative of the function. You haven't, because I didn't tell you that any derivative. So a derivative is not continuous in the way you think of a function at a point. The derivative is the rate of change of a function at a point, right? And we can choose one point or we can choose all of the points over a continuous function. But the derivative itself is not something that's continuous, right? It changes constantly. Does that make sense? Derivatives change.
You can't find the derivative at a removable discontinuity, Ms. Wilson?
You cannot.
You cannot? Okay.
Mm-mm. Does that make sense, you guys?
Yes.
Well, the answer is C. So the student
Yay.
your girlfriend
I got it right.
in class and put that away. So C is correct. C is in Charlie. All right, so those are things to ponder. And what we're going to do with the, hey, I did it again. No, your slide went away. I swear I made the other slide. Maybe it's under here. No?
Oh, you're looking for a slide. That's
Yeah.
what it was. I was like, why is it going?
The agenda. So we're going to continue on with related rates. It's on the board. I know those at you at home can't see it. I did have another slide that said we were continuing on with related rates, but I don't know what happened to it. So anyway, I'm going to unshare this. So see, those are good little food for thought practice problems. And I'm going to now share. Oh, that's what that is. I'm now going to share. So what I'm going to do is this. I'm going to share my Zoom here on my iPad, and I'm going to pull the book out, which I already have out, and go to that page, and I'm going to do, so I'm not going to project the problem because, or the problems that were requested, because, you know, it's hard to write in the little spaces in the book. So I'm just going to use a blank piece of paper on the iPad and go from there. So what were the problems again? There was 14 and there was some other one. Which one? 3?
3.
3. Okay. So in number 3, we have that if r over 3 is equal to h minus 4 over h, then they want us to find dh dt when r is 2, h is 12, and dr dt is 1/2, right? So I know that's tiny writing. Let me turn it. So remember, I'm trying to do like an IMAX theater in the classroom, although I'm far from it. So what we need to do is differentiate this thing and then plug those numbers in as follows, right? You never ever plug numbers in first, ever. So let's take the derivative. On the left of this, you can think of this as 1/3 r. And on the right-hand side, there's really not much that you can do. But anyway, what's the derivative of r thirds or 1/3 r? If we're differentiating with respect to time. 1/3 r prime or dr dt. Is that okay, everybody online? You could do 1/3 r prime too. You can use either notation that you want. Either one is fine. Anybody want me to do it in a particular notation? The reason I'm choosing this one first is because they're asking us to find it in Leibniz form, and generally you want to stick with the form that they ask you for. So I'm going to use Leibniz notation because that's the form they gave me to begin with. That's what they're asking me to find. All right, so on the left, our derivative's done. And what about on the right? What in the tarnation? Yeah, quotient rule, right? So quotient rule says we take the derivative of the top. Now remember, we're taking the derivative with respect to time. So if I take the derivative of h, it's 1 times dh dt. Is everybody okay with that? Oh, what am I doing? Hang on. So derivative of the top times the bottom minus the top times derivative of the bottom over bottom squared. Are there any questions with what I just wrote down there? Anything? Remember, you're going to get a 5, right? BC. So we're good? Everybody's being very quiet online.
Yeah, that makes sense so far.
All right.
Yeah, it makes sense, but I don't know about a 5.
Isaac, you gotta believe in yourself.
I'm thinking a 3 again.
Believe in yourself, Isaac. 5. You got this.
You will get a 5. Okay, so we took our derivative, right? And what they gave us over here is, you know, they gave us a value for r, h, and dr dt. So I'm going to just start plugging in. So we've got 1/3. Now dr dt is a 1/2, right? Is equal to dh dt times h is 12 minus 12 minus 4 times dh dt. Now I could have factored that out too, by the way, probably I should have, over h squared, right, over 144. So it looks like we've got 1/6 on the left is equal to, if I factor out the dh dt on top, I'm left with 12 minus 8. Is that okay? Over, I mean, I could have just collected like terms, but anyway, over 144. And what I'm going to do there is I'm going to multiply both sides by the reciprocal by this thing, the reciprocal of this thing. So I'm going to have 144, 12 minus 8 is 4, right? over 4 times 6 is equal to DHTT. Did I do that right? And 144 divided by 24 is what? Anybody get an answer? Is it 6?
Yeah, 6.
Yeah, because 6 times 2 is 12. That's 12, and then 2 goes in 6. Right, Okay. So is that okay for whoever asked me?
Yeah, I did it really wrong on the homework, but this makes more sense than what I did.
Okay, so now you're going to get it right, right?
Of course.
That's what I would think. Okay, so that was number 3. There was another one, I thought. Just 3 and 14? Okay. 14 is a fun problem, yeah. All right, so in 14, you have a rope over a wall. So here's my wall, okay? And my wall is 12 feet high. And I've got a rope hanging over each side, which is nice because this is the ground. And so I'm thinking right triangles, right? And right triangles is a good thing. So the rope, the whole length of the rope, so I guess I'll call it length, is 35 feet long, right? And each end of the rope is tied to a cement block, like so. And one block is being pulled away from the wall at a rate of 30 feet per minute. So I'm gonna, it doesn't matter which side you choose, but I'm gonna call this distance X and this one Y in alphabetical order. I could have made this, I could have made this side X and that Y, but anyway, I'm just gonna call this distance X from the block to the wall and the distance from the wall to the block on the right side of the wall, Y, okay? You can call it anything you want. So I'm going to say that dx dt then is equal to 30. The rate at which it's being pulled away from the wall is 30 feet per minute. At the moment that the first block is 16 feet from the foot of the wall, how fast is the other block being dragged? Okay, well, let's see what we got going on here. If I think about the left-hand side of this thing, I know that the left-hand side could be rewritten as the square root of x squared plus 144. Why? Yes, Zach?
Pythagorean theorem.
What about the Pythagorean theorem?
We can use it to find the length of the rope.
But I've got the x there and I've got the 12 there. Where did the 144 come from? I mean, I'm sorry. Say that, where the 144 come from. Never mind. Yeah, right. Sorry, I just had a senior moment. So anyway, if this side is x and this length is 12, right? Then z squared, that's what I'm going to call the length of the rope or the rope side, is equal to x squared plus 144. If I take the square root, I only need the principal or the positive square root. So there it is, right? And on the right-hand side, I can do the same thing. That's just going to be the square root of y squared plus 144. So I have equations for each side of the scenario. Now, what do I know? Well, I know that if I add those two up, they should equal 35, yes? So I can say x squared plus 144 under the square root plus root y squared plus 144 is equal to 35. And then what do you suppose I'm going to do? Derivatives, that's right. And if you want to rewrite this, and I suggest you do, so let me just improvise here. But if you want to write it like this, that's fine too. And we're taking derivative with respect to time, let's not forget. So, and this is a plus. So anyway, if I take the derivative of this term, I'm going to have 1/2 recomposed with the stuff inside to the negative 1/2 because I'm subtracting 1 from the power times the derivative of the inside. Well, that's 2x dx dt, right? Is that okay so far, you guys? Online, you're being super quiet, so it's hard for me to know.
Yeah.
And then I'm going to do the same thing for this term, right? We're going to have 1/2
y squared plus 144 to the negative 1/2 times 2y dy dt is equal to 0 on the right. And again, you know, if you wanted to use prime notation, that's fine too. Now I'm going to clean this up a little bit more. So I'm going to rewrite this. Let's see, these 2's will cancel, right? So I'm going to write this as x over root x squared plus 144 dx dt. The 2's here are going to cancel, so we're going to have plus y over root y squared plus 144 dy dt is equal to 0, right? Now I'm going to go back to the problem because it says at the moment that the first block is 16 feet from the foot of the wall. So I'll let this be the first block over here. So when x is equal to 16, we're 16 feet away from the wall. It doesn't matter what block. I'm just going to use x. Then what do I know about the block on the right? If x is representing the left-hand side, what do I know about the block on the right? Well, I know it's moving toward the wall, right? If we're so. No, it's okay. So if we're pulling this block out here, then that means this block's moving closer, right?
Right.
So at the moment that this is 16 feet from the wall, the x side, what we're asked is to, so let me just make sure I'm reading right. At the moment that the first block is 16 feet from the foot of the wall, how fast is the other block being dragged? So what we're looking for is dy dt, right? We want to know how fast this is being dragged. I'm sorry. So dy dt is what we're looking for when x is 16. Capiche? So now what do we do? Well, at this point, if you wanted to, you just plug in 16 for x, right? And but we got to figure out something else. If this is 16, then we've got, this is not 121, by the way. I keep looking at it as 121. It's 12 feet, so I'll just put a 12 there. But we can find the numerical value for our z here, right, by using Pythagorean theorem, correct? So 144 plus 16 squared is the square root of what? What does it equal? Anybody know?
I mean, length is 9.
This is 9?
Yeah.
Okay.
No, that's not 9. That's 20.
Oh, you mean the thing up there?
That's
20.
Oh, that.
Oh,
up
that.
there is 20.
That, yeah.
Oh, okay. All right.
Also,
All right.
The other, 15 left over. And it's not the road.
Yeah. Uh-huh.
Then y would be 9.
Yeah. Okay. Okay. So if this is 20, right? Then all I have to do, and remember, this length is not going to change. It's going to be 35 regardless, right? But at this point here, you can just plug in and solve. And you're trying to solve for this baby right here. You're trying to find dy dt, the rate at which this other block is being pulled toward the wall. So do you think you can take it from there? It's a good problem, right?
It is a fun
Yeah.
problem, Sultan. I did it
It's a
once, but
good
it's
thinking
fun.
problem.
That's the fun thing, is you can do it.
You can do it so many
Wait, how'd you do it, Zach?
I just took I found first the rate at which the rope was moving.
Okay.
And since the rope is going to
Yeah.
move at a consistent speed, since it's one solid object, I just used that to find.
I was gonna do that.
It was a lot less math.
Oh,
It was short.
That's a shame.
And I was like, okay, well, this is okay.
Yeah, you could approach it many different ways.
I got 40 feet per minute.
Let's see. Hang on. I don't know what you got 42? Okay, so the answer should be 40. What was this, 4.6? Is that our section?
Like this large. That's actually fun.
Oh, I can give you more problems like that.
I got 40. Wow, that's crazy.
What did you get?
I got 40 like the first time I did
Good,
it.
very good, very excellent. Pat yourself right on the back. Yeah, 40 feet per minute. Yep, that's exactly right.
Let me know the direction. Yeah, if you drop a sign somewhere.
So, you just think about it and try to put it into perspective mathematically. And again, there's always more than one way to approach a problem in math. That's the beauty of it. But this was, I thought, a fun little problem. And for those of you who hated this problem, I apologize, but you will get more. So keep that in mind. Let's do some winches today, shall we? Winches and shadow problems.
We haven't done shadow. I'm so excited. I'm very excited this week.
You are. Most kids hate shadow problems.
Shadow problems. This is unexciting. Flores, put everything down. Your girlfriend not important. Shadow problems. You can help her calculate the length of her shadow.
That's not a very long shadow.
You can do it at home. I used to do it. So, you walk by a street light. So you go down to the street when it's dark enough out to create a shadow. And not Nebraska, please.
Listen, I live off Nebraska. What do you want me to do?
So do I. Walk in your neighborhood where it's safe. No one's wearing masks.
No, school has like 19 cases.
What school? Really?
Do we have
Isn't that
any cases? I feel like
Riverview
we
has
have
like
six. What?
Riverview
had like
6.
Wow.
Have we had any? Like, I haven't heard any of them in
No,
here.
but my local high school is pretty cool.
Okay,
That's
let's go back. Let's focus. Let's focus
Bring it
back.
guys. Shadow problem time.
Let's focus. So let's see. Let's do a winch problem first. I love winch problems. They're very easy and they're cute in my opinion. And I'm going to try this again. I don't know why it's asking me to take a screenshot. I just can't stand it. So what I'm going to do is I'm going to do number 12, which is in the book, all right, from that section 4.6, but I'm going to do it on blank paper, all right? So I'll kind of read it as I got it. I'll kind of read it as I go over it. So in number 12, it says a winch at the end of the dock is 10 feet above level. So in case you don't know what a winch is, here's a dock. All right, the dock is 10 feet, the dock here. So here's the dock, right? And what there is a winch is a little circle, like, I don't know, you're probably too young. There used to be in the olden days when I was a kid, clotheslines, and one circle would be attached to your house and the other circle would be attached to a tree like 5 miles away from the house, and it would have this clothesline like this on it, and you could put your little shirt on there and then push the rope out and then get another blank spot of rope and then put, I don't know, your pants on there. You guys know what I'm talking about? So a winch is like a little circular device. If you think of a fishing rod, the thing that you wheel in the, what is it called, fishing line? That's a winch, okay? It's like a little crank that you can turn to pull something in with, okay? So that's a winch. So here's my little winch. It's this little circular thing. It's at the end of the dock, and the dock is 10 feet above the level of the deck of a boat. So we've got some little boat out here, all right? There's my boat. And this distance between, so the boat's in the water, right? And the distance, let me just make my picture just a little better, okay? So here's my, so here's my dock, all right? And it's 10 feet above the, I'm gonna put my 10 here, 10 feet above the level of the boat. I can't draw, okay? So I'm doing the best I can. This is my, this is my dock. All right, the rope attached to the deck is being hauled in by a winch at a rate of 5 feet per second. So what I know is that this rope here, I'm going to call it Z, is being hauled in, DZ dt, at a rate of 5 feet per second. You notice I'm putting a minus there. Why am I putting a minus by the 5? the interval between the boat and bashing into this deck or whatever, dock, is getting shorter, right? And the interval here to here is getting smaller, right? The rope is decreasing. So when something's decreasing, we include a negative. How fast is the boat approaching the dock? So we're looking for dx dt. So the boat's going to come in this direction toward the dock when there are 26 feet of rope out. Well, again, this is a very terrible picture.
Beautiful.
No, it's not. It's
like
really
the Mona
bad.
Lisa, but a boat.
So what I'm going to do is try and do this. This is usually how I draw them. This is my dock and my winch here, right, with the rope coming out. So what do you see that I just formed there? You see how long it took me to form a triangle? A right triangle, right? So does that give me the geometric formula I need? Yes, it does, right? X squared plus y squared equals z squared. Now, the thing is that is everything in motion? The boat is moving toward the dock. The rope is decreasing as we're hauling the boat in, but the height of the dock is not going to change, right? So I would probably let this be my x direction, this be my y direction. Of course, I already named this side as z. So this is nice because what you can do here is, since the dock is not changing, it's a constant 10 feet, then what you can do is write x squared plus 10 squared is equal to z squared. And take the derivative. What's the derivative of the first term with respect to time, people?
We're not playing yet, so 2x x prime.
Okay, 2x x prime. What's the derivative of 100? Is equal to 2zz prime, right? And can I cancel the 2's out? Yeah. So yeah, what I have is xx prime is equal to zz prime. And now, can I fill in the rest? Well, let's see. I know what z prime is. It's -5. I'm looking for x prime, so that's okay. What am I going to do about x and z? Well, I know what z is. It's 26, right? I want to know the rate at which the boat is coming in at the instant there's 26 feet of rope out. So what I know so far is I've got x prime, the thing I'm looking for, is equal to 26 times -5. Well, what is x?
$24.
Yeah, if z is 26 and y is 10, then Pythagorean theorem says this is 24, right? So what I've got is 24x prime is equal to, that's a 30, carry the 3, 130.
130.
Right? Is that right?
Well, negative, technically, yeah. That's what I got.
All right. So x prime is -130 over 24, right? And I don't know if that reduces down nicely or not.
65 over 12.
Nope.
65 or 55?
65.
So -65/12. By the way, we would normally leave our rate in that form, okay? I mean, sometimes you'll use decimals, but most of the time we just leave it exact. And how would we state our interpretation of this scenario?
The boat is getting closer to the dock at a rate of at a rate of 65 over 12 feet per second. At the moment, there's 26 feet of rope.
Beautiful. Okay, or something along those lines. We're good? Are there any questions on that? Okay, so that's a winch problem. Not a winch, a winch. The boys used to say, it's a winch problem. You know, for buccaneers, pirates, anyway. All right, so 15 is a street light problem. And we're not supposed to be in lockdown or anything, are we? We're not supposed to be in
It's
lockdown.
pretty sweet.
Oh, so they come and shake your door.
If you are, good luck.
Those me shaking in the chair.
So we've got a street light. We've got a street light that is 15 feet above the sidewalk. So I draw as I read, okay? So here's my street light, and it's 15 feet above a sidewalk. Here's the road or the sidewalk, right? This is the light. And a man 6 feet tall is walking away from the light. So here's the man. He's 6 feet tall, and he's walking away from the light at a rate of 5 feet per second. So I'm going to say dx dt is equal to 5, okay? And the question is, A, determine a function relating the length of the man's shadow to his distance from the base of the street light. So where is his shadow going to be? In front of him or behind him if he's walking away from the light? In front of him, right? So I can call this S for shadow if I want. I don't like to use S because my S's look like 5s, but it's S for shadow, okay? And I call the distance between the person and the light X. He's some distance from the light. And the other thing I do, okay, what the hell is going on in the hallway? The other thing I do is I attach the light to the ground with a hypotenuse. Always do that. So what you're going to use to help you with shadow problems is similar triangles. So again, this is the letter S here for shadow.
Mrs. Wilson, could you just do a cursive S?
No.
Oh, okay.
I could, but it looks weird. Anyway, so how could I write, what was the question? Determine a function relating the length of the man's shadow to his distance from the base of the street light. So if you're thinking about similar triangles, what do you suppose we could do to come up with a function?
A proportion?
Okay, so what would the proportion be?
Well, you would have, I think you would do the 15 and the 6 with something, and then, I don't know.
Okay, so this side is to this side, right? So let me use my pointer. This is to this, Now I'm going to
do,
yeah.
never mind. Go ahead.
Oh, no, go ahead.
I was thinking that maybe we could do the, like the S, it is to X plus S.
Okay, nice. I almost forgot. Another little trick I like to use is you see how I connected part of the street lamp or the pulse that's holding it to the man's head? Because if I do that, then, you know, maybe it'll come out in helpful, because if this whole lamp is 15 and the guy is 6 feet tall, then that means that this is 6. So the whole thing's 15. I don't want to forget that. But if this is 6, then this must be 9, right? So, you know, yeah, I could do 15 is to 6 if I wanted to, as what is to what? X is to X plus S, is that what you told me?
Yeah, but it'd be S, well, X plus S to S because
Good, because I don't want to screw up my proportion, right?
yeah.
Yeah, so I started out with big triangle is to small. So I have to do the same thing here. Big length is to little length. So X plus S is to shadow, yes?
Yeah, that makes sense.
All right. So in part B, it says determine the rate at which the man's shadow is lengthening at the moment that he is 20 feet from the base of the lamp. Can you figure that out? I think you can. I want you to try.
How far?
20. He's so when at the moment he's 20 feet from the base of the light. Determine ds dt when x is 20. This is the question. And the question I have is, can you solve it or can you find it? And I think you can. And with that, I've got to pull up my related rates. This one. Packet because I forgot to do that. Actually, I did a pretty nice drawing, I think. Okay, there. So, let's see if it's in here. I'm going to have this fun little related rates packet for you guys to do. I just haven't put it into Canvas yet, so I'm looking something. Here, hang on. Close. So annoying.
Do you get 5 feet per second?
I don't know. Hang on, I'll let you know. What number was that again? 13, 15. Was it 15? Nobody knows. Yeah, so.
You have 5 written for x prime.
Right, we're looking for ds dt.
Yeah, but did Estella just ask? I think she just asked what dx dt is.
Oh, the units?
Yeah, what are the units?
Feet per second. I'm sorry, feet per second. Yeah, sorry. Lexar, related rates. There's a related rates quiz. Lars, did you get an answer? Why not? You know what? It's time for you and the girlfriend to break up. You need to keep.
I'm not even texting.
It doesn't matter. When you date, then the other person's on your mind. So we got to erase your mind of all.
Mind wipe. It's like
I promise that I forgot all about her to sacrifice my mind to
You
shadow.
know, if I tell her that, she will dump you.
No, she won't. I'll tell her right now.
Calculus more important than any girl. She would understand.
Exactly.
She would understand.
Academics
She'd be
is
like,
always
of course.
more important than any relationship.
Yeah, I would have to break up with you until you know.
So you get your
This
PhD.
is our calendar. We're broken up for on these days, on these.
Don't
message me.
on alternating days.
Oh.
155 to 325 on alternating days.
The IB kids used to say, you know, so-and-so's fighting with his girlfriend or her boyfriend or whatever, and it's a terrible relationship, but at least they have relationships, because we don't. Some of them did, but a lot of them wouldn't, because they didn't have time for a relationship, and I would remind them of that each and every day. If I saw a twinkle in somebody's eye, I'd be like, get rid of it, because you got to do this.
That is so hard. That's so smart.
I know. It's true.
Oh, you're happy? No.
Erase all
How dare
happiness.
you?
Okay, so what did, Estelle, you got an answer you said for?
I got
5 over 3? Not 10 over 3? Well, maybe not. Maybe you wouldn't have. You didn't necessarily. I think I may have, and only because I always think of the tip of the shadow, because there's a difference between the motion of the shadow and the tip of the shadow, believe it or not. And so let's see here. And I drew this with the intention of telling you guys something, but I forgot. Did anybody use this little triangle up here to help with anything?
No, I didn't.
You could have. So, you know, if this is x, isn't this x too? X?
Yeah, so I just put 9 over x.
Yeah, 9 over x is, or sorry, 9 over 6. Yeah. Yeah. 9 over 6 is equal to x over s, right? 9 is to 6 as x is to s. Yeah. So then s, if we solve this thing for s, s would equal to 6/9 x. Is that right? Or 2/3 x. Is that right? So if we take the derivative of s with respect to time, we would have 2/3 x prime. Is that right? Which is 2/3 times 20. So yeah, 10/3. Okay.
Oh, that makes so much sense.
Isn't that cute?
Yeah, I just messed up.
It's a lot less messy than using this one. This one we'll usually use when we're dealing with the tip of the shadow, but yeah. Isn't that cute?
That's so awesome. Wait, what did you get for your answer?
10/3.
That is so
Did you get that, Zach?
No, I kind of screwed up somewhere with those. And I used that complex one. You know, I kind of just got.
I was trying to go with that.
Yeah, so this is S, right? So let's see. So if I multiply both sides by S, I have S times 15/6 is equal to x plus S, right? So 15/6 S minus S is equal to X, right? Now, if I multiply by the reciprocal, I have to multiply every term both sides by the reciprocal, correct? So I would get S minus 6/15 S is equal to 6/15 X. Is that right? I don't think that's right. Let's see. What's 1 minus 6/15? It's 9/15. Is that right? Which is 3/5, right?
Yeah.
Okay, so 3/5 S is equal to 6/15 X, right?
Yeah.
And now let's take a derivative. So we've got 3/5 S prime is equal to 6/15 X prime, right? If I multiply both sides by the reciprocal of 3/5, that's going to give me S prime is equal to 5/3 times 6/15 X prime. And let's see, this is a 3, and so that's 2/3, right? You see how much more work that is? So I was going to make you do it that way initially, and then I drew the little line from the guy's head, and I was like, hey, look at this. And then I forgot. So anyway, yeah. And so now you would plug in, you know, your rate of change for X, which was, I don't remember.
Wait, what was the simple way you
5.
did it again, Miss Wilson?
Okay. Yeah. No, it's all right. So you got to get a lot of work to get down to this point, and then you plug in, right? Whereas it's a lot simpler because you've got more numbers, you've got less. So don't get me wrong, there's gonna be times when you have to do that, but everybody's okay with my little picture here, right? So whenever you have a shadow, what you want to do is you want to connect the guy's head. Oops, I didn't mean to do that. Somebody's in the waiting room. All right, thanks for letting me know. I'm letting you in. I'm letting you in. Waiting room. I'm coming. Okay. What you want to do is, you know, you've got the whole great big triangle. You've got laser. You've got this whole big triangle here, right? And you've got this little triangle here. So, you know, you could use that. You could do big triangle is to little triangle, right? Use the proper ratios there. But sometimes what's a little bit nicer is that, you know, in this case here, we can use this triangle, right? So that's what was done over here, I think. I think this is the part. And we did 9 is to 6 as X is to S. And generally speaking, it's just going to be a little less complex. Why? Because when I do this is to this is X plus S. So then you got a lot of work kind of to whittle it down to, you know, take your derivative. So if you can use this length is to this length as this height is to that height, then it's generally a little bit easier. Let's try another one, shall we? I erased it. All right, hang on, I'll put it back. I'll put it back. Here. Can you see this? It doesn't matter for what?
The distance the man is away, because I never put X back in.
Well, you didn't have to. You never plugged X back in?
Yeah, it's like when you average.
Oh, right. So yeah, I see what you're saying now. Right. After you take the derivative, there's no X to plug in. Right. The distance he's away from the light is going to have an effect on his shadow, but not on the distance between him and the light, because that is the distance between him. That doesn't make sense. I'm trying to say it. The distance he's away from the light is going to have an effect on the shadow. The further he gets away from the light, then the shadow keeps changing.
Now I get it. I'm sorry.
No, it's all right. Do you guys online see what I did there? Is that okay for you guys? Is anybody online?
I'm online. It was kind of wacky. I understand kind of what you did. I tried doing it without the like line that you drew from the guy's head at first, which confused me a lot. But the simpler way you did it made more sense, but still kind of confusing.
All right, so I found the packet that I was looking for. And I'm going to give you, well, this is dumb, but anyway, they're giving you a hint here. But let me share this screen. I'm going on to one of my many screens. I just have like the whole room surrounded by screens. But what Estella said is that his distance away from the light does not matter, and it doesn't. Let me unshare this. And let me share this screen. And so let's have a look. Cool. Okay, now here's the deal. I want to see if I can make this big enough for the kids in class to see. I might be able to. So how do I zoom in on this thing here? So this might be too much, but number 4 here, we've got a 7-foot. We've got a 7-foot person. I don't know. Can you all read that? Estella, can you see it from where you are? But a 7-foot tall person walking toward a light now. And the rate at which he's walking toward the lamp is given. Assume the scenario can be modeled with right triangles, of course. At what rate is the length of the person's shadow changing when the person is 12 feet from the lamppost? So try this one. And try connecting his head to the lamp, not in a violent or vicious way. You can't read it? Can you not see it? Yeah, well, look at Mr. Hines then. I think he's 7 feet, isn't he?
He's 6'9".
6'9" already. Might as well be 7 feet.
How tall was Mr. Rivers, though?
Who?
He left
Mr. Rivers, he was an AP before you got here, I think.
He was, and was he 7 feet tall?
I think he was about
He was
that
like
tall.
6'8", 6'9".
Really? Oh my goodness. So while you guys are doing it, I'll get a blank sheet here and work it out, and we'll see if we all come up with the same answer. Oh, I don't want to do that. So that there.
Is this our homework?
What?
Is this our homework?
Well,
Or-
it will be, but for right now, I want you to be working on number 4 so I can see if you get the right answer.
Okay, yeah, the one with the light bulb. Okay.
Yeah, the light post. You got an answer? What do you- Really? So you would say that the length of his shadow is changing at the rate of 14/5 feet per second at the instant when he's 12 feet from the
got that.
lamppost. You got that too?
Yeah.
Yay!
I didn't use the line from the person's head. I just took the initial proportion and I just cross multiplied.
You did 17 is to 7
Yeah.
as what is to what?
I just used the same variables that we did last time and I just cross multiplied them.
Okay, but as x is to what? Or
I did
s.
x plus s is to s because I did 17 over 7.
Oh, okay, I see. Well, where is his shadow going to be if he's walking toward the light?
Behind him.
It's behind him, right?
Okay, I got it.
And you got 14/5 too? Good. Now, can somebody tell me why you're coming out with negative 14/5?
Because we defined left as negative.
Well, I mean, technically, it's getting smaller because he's getting closer to the light.
Nice. So in case you didn't hear that, he's walking toward the light. And eventually when he's like right at the light, his shadow's going to be teeny tiny, right? So in other words, the distance between him and the lamp is collapsing to 0. The width of the interval is collapsing to 0. And so this negative just means that the width of the distance between him and the lamp is getting very, very small or smaller. So that we're walking toward the light. We're going toward the intersection, right? Any questions on that? Are there any questions from anybody online with this problem?
Not from me.
Are we gonna do the point of the shadow, you said?
I don't know if he has any tip of the shadow problems in this book.
You can make one up.
No, they're not that easy to make up, actually. But I have some. And I'll bring some for next time for fun.
Shadow regarding the distance that is from the lamppost?
From the person.
How would that be different? For finding how the length of the shadows changing, so I think.
Yeah, so there's the length of the shadow that changes, and the rate at which the tip of the shadow is moving.
Yeah, there's shrinking shadow.
Will they ever give you the rate of the shadow and ask for you to find like how fast they're moving towards or away from the pole? I mean, that's the same process. It's just
It
a
is. I haven't seen, no, usually they ask you about the shadow length is generally. Yeah, and in fact, if I go into, so those of you online, I'm waiting to hear if anybody's got an issue, a problem, a question, please let us know. Is this the yeah. So let me find shadow. Ooh, here's one from AP. This is a BC problem from 1988. You want me to post it? You want me to put it?
Do it, Miss Linda.
Do it.
All right. So let me share. Let me stop this. Oh, wait. Oh, you can see it. Okay, never mind. I'm there. Let me make it bigger. Hang on.
Well, look, this one does give you the length of the shadow.
The shadow is lengthening. It is growing.
Oh yeah, they're asking what rate is the person walking.
There we
So
go.
yeah,
My question has been answered.
it has.
1988. They thought.
In 1988.
This is unique. No one's ever done.
In 1988.
1900.
Let's see, 163. 160, 180. Can you guys all see that okay? Those of you online, can you see problem number 37 here okay?
Yeah, it looks good to me.
Okay, try that one. So it was 1988, number 37. So a little bit of a twist, but generally speaking, in AB anyway, they always ask you for the length of the shadow. I forget that I'm in BC sometimes when I'm teaching AB. So,
That's fun. That's no problem.
are you done?
Yeah.
What'd you get? What letter choice?
D.
D as in dog?
Yes.
Oh, yesterday I saw a dog and I think somebody dumped it off. And when it saw my car, it ran up to my car like I was the owner and I wanted to take it and I couldn't. Because my dog's terrible with other dogs.
My dog's just fat and lazy. We won't even go for a walk. I'll put his collar on. He just sits there like, okay. I don't know what you want to do with this.
My neighbor has a bulldog that's
Yeah.
freaking cute and it's a gray. So it's this really beautiful blue eyes and gray colors. And anyway, she'll be walking. Her name's Penny. She's still a puppy. Then she'll lay down. She will not move. And she weighs a ton for a puppy. I mean, it's like, oh, like dead weight. She won't move. He's like, Penny, get up. Nope. I'm laying down now. She gets tired really easily.
Yeah, my dog will walk around for about a minute. He's like, I'm tired, man. That'll be a fun dog. He has his spurts of energy for like 5 minutes and then he's done for the day. That's his workout.
What kind of a dog is it?
English bulldog.
Oh, okay.
Yeah, so that's why.
That's why, yeah. Those are the best dogs.
He's cute though.
Oh, yeah, they're very cute.
Just that's really good.
That's the kind of dog I should have gotten. I love my dog, don't get me wrong, but she is insane, high energy, high maintenance. She doesn't stop.
My dog's high maintenance because he always smells and he sheds 24/7 every day of the year.
Too.
Just like constant.
The vacuuming is never ending, and it doesn't really help.
Yeah, because then it's back the next day and you're like, oh, okay.
Or the next hour.
Yeah, the next hour, my bad.
So children online, anybody else get an answer? Did you get D as well, Estella? Okay, did anybody not get D and want to go over it? Lauren, are you okay with this problem?
I'm still looking at it. Like, I just don't really understand the proportions.
Okay. Let me share my iPad. However, this document that I have here, this is like from 1969 all the way to 1997 of all the prior AP multiple choice for A, B, and BC and FRQs. I can't share that document online, even though I own it because I bought it. I'm not allowed to share it online per AP. Doesn't matter, I bought it. But, so I'm going to stop sharing here. And let me pull the document up so I can read the problem. Here it is. Okay, so I'm going to show you. So, share the screen. Oh my gosh, it's almost time for the bell to ring. See, time flies when you're having fun.
We're having so much fun in here, Miss. We did shadow problem? A winch?
Hey, Miss Wilson, I have a quick question.
Yeah.
So, when is a test?
Probably.
Learn calculus. Doesn't matter.
The test is probably going to be, I'm just checking to see, I think there's one more section past this one. There is. Local linearization, which is an easy section. Oh yeah, no, okay. So I forgot your BC. So normally in AB, we skip 4-7 because it's Newton's method. And Newton's method is a pain in the wazoo, but Newton's method is extremely important because you're going to be tested on it. So I would say your test would probably be, so today's Tuesday. I would say next Friday. Zach, I'm going to wring your neck. It's that woo.
Okay.
Okay. So yeah, probably next Friday, because we're really overdue for having an assessment. So, and again, I'm trying to kind of hold off because I know kids are out of class doing testing and all that stuff. So anyway.
Miss Wilson, would the test be on chapter 2 as well, or just chapter 4?
Yeah, I'm going to include some stuff from chapter 2. I think you guys can handle it. Yes? Yes? No? Ooh. So I know we went through chapter 2, but we should be proficient in it. So if you're not, email me on the areas. I mean, we're going to have a test review and everything prior to having a test for everything that's going to be on the test. But email me what sections in chapter 2 that maybe you're struggling with, so I can do like some little side videos and send them to you or something.
Okay. If we have a review, then I think I'll be good.
Okay.
Thank you.
All right. So Lauren, we have a person that's 2 meters tall, right? Walking away from a light. So here's your light. Dang this thing. Here's your light. Here's your light. Here's the ground. And here's the person, right? And they're 2 meters. 2 meters. And it's the street light is 8 meters. So this whole distance here is 8 meters away long. If the person is walking at a constant rate and the person's shadow is lengthening, so what they're telling you is ds, the rate of change with respect to the length of the shadow with respect to time, is 4/9. And the shadow is getting bigger, right? Because the person's walking away from the light. At what rate is the person walking? Well, what did you guys name the person walking? W? I want to find DW, DT? So I don't know, let W be walking. All right, so again, the person's 2 meters tall. I've got right triangles. And the idea is you want to use similar triangles. So if I get rid of the little guy I made here, I just use a line, you know, so here's his head. This is 2 meters here. This is 8 meters. Now, if I do this thing here where I connect the top of his head to the side, if this whole length here is 8 and he's 2 meters, then 8 minus 2 makes this little bit here 6 meters, right?
Yeah.
Okay. So again, we want to find the rate at which he's walking. Am I saying that right? Am I interpreting that right? At what rate is the person walking? So how are we going to set this up? I know the rate of change of a shadow, and his shadow is here, S. And I know ds dt is 4. What else do I know? Or does it matter? Well, how do we set up the proportion?
Before you're doing stuff like the side of the large, like the 6 meters to the 2 meters is to the like horizontal space to S, I thought.
Right. Okay. So I thought that's where you were having trouble. I thought you said you're having trouble setting up the proportion thing.
Well, it's not so much like setting up the proportion, but like that's the last step. And then I don't know what you're doing after that.
Okay. Well, once your proportion is set up, you just take the derivatives of both sides and then plug numbers in. So what you would do then, you're telling me, is you would do 8 is to 2? Yes?
Yeah.
Okay. 8 is to 2. As what is to what?
Whatever you would call the line from the guy's head to the 8 meters, and
Okay,
then
we'll call it
is to S.
W.
Okay, and then as the W is to S.
Like this?
I
Does everybody
think
agree
so.
with that?
Or would it be W plus S to over S?
Why not, Estella?
Because the, so the 8 corresponds to the overall large triangle, while W
Right. So that's, I think, where maybe you're having a little, I don't know if you could hear her.
Yeah, I meant to say
You can-
W plus S over S.
Okay, so you're, all right. So you're calling it W plus S. Yes?
Yeah.
All right. So like this. Yes?
Right.
All right. So, all right. 8 halves is 4, right? So I'm just going to say equals 4. Is that okay?
Yeah.
All right. So now at this point, I need to take the derivative of the left and the right. However, I mean, I can use the quotient rule on the left if I want to, right? It's a quotient.
Yeah.
But a lot of times it's better to maybe rewrite it if you can. So what I often do is I'll multiply both sides by S, right? So I get 4S on the left, and if I multiply over here, it cancels, right? So I have W plus S is equal to 4S. Is that okay?
Yeah.
All right, and now I can combine like terms by subtracting S from both sides, right?
Mm-hmm.
So I have W is equal to 4S minus S gives me 3S, right?
Yeah, that makes
Okay,
sense.
so if I want to, I can divide by 3 now, or I can leave the 3 there. But the idea is at this point, you know, you might want to say 3S is equal to, well, actually we'll solve for W, so I'll keep it on the left. It doesn't matter. But if I take the derivative on the left, I get dW dt is equal to 3 ds dt, right? Because we're taking the derivative with respect to time.
Right.
This is the thing we're supposed to be looking for. And over here, I know that ds dt was 4/9.
4/9 is, and then you just plug it in.
Yep.
Okay, that's a
So
lot easier than I
4/3
realized.
the answer you guys got? Is that what you said?
Yeah.
4/3? Yeah.
Okay.
Oh,
Is it? Cool. I think we're supposed to get a cold front, you guys. It's supposed to be like in the, yes, in the 60s.
Thank God.
Yeah, me too.
cold today. It was not. It was so cold.
How do you say it's so cold? It was humid and miserable out when I left. You better move to the equator.
Yeah, in the school maybe.
Yeah, I'm cold right now, and here I got this thing on. And when I proctored in that room, it's like 40 below zero. It's cold in that room. So, Lauren, does that help?
Yeah, that made a lot more sense. Thank you.
Okay. All right, so listen. The bell's getting ready to ring. Shh. The bell's getting ready to ring. So what I'm going to do...
Oh, you have 10 minutes.
I do? Oh.
That's 9.
All right. Well, you know why? Every clock in the room is wrong, and I always fail to look at the little clock on the computer or my cell phone or something. So what I'm going to have you guys do, let's do one more problem real quick. How about, can you do number, oh wait, you don't see number 3. Cool. So here, I'm going to have you do one more problem, and then I'm going to post this document onto, yeah, stop the other screen shares. I'm going to post this onto Canvas, and I'm going to assign some random problems for you guys. So Number 3 is water is leaking onto a floor, forming a circular pool. These are really rough, I know. So what I'm thinking is you should all be able to solve this problem in like a minute and a half or less for real. Number 3, can you deal with it? A minute and a half or less. Now, can I pin this screen?
Good afternoon,
See,
Tigers.
this is why I wanted to stop, because the announcements never stop
It's
when we
now
have
time for
my
your
Tigers.
afternoon announcement. A reminder, picture day is tomorrow and Thursday.
No,
Tigers, your school
September
pictures will be
31st.
taken during your English class.
We don't
These
have a
pictures will be
September
available for purchase
31st.
and will also be used in the student yearbook, as well as for
Really?
student ID. If you have any questions, see Ms. Kara Smith, our yearbook advisor.
3 months
A
past
reminder that conference
September,
night is this Thursday from
April,
4 p.m.
June,
to 6:30
November.
p.m. via Zoom.
all have
Student
30
links for
days.
your classes are
The
on
rest have
your teacher's Canvas
31.
page. Congratulations to our Tigers swim team for last night's win against Chamberlain.
What?
Tonight, we
What did you
extend our
get?
support and good vibes to our Tiger varsity volleyball team.
216 pi.
The game time is 7 p.m.
Hero.
And finally, we extend a happy birthday to our principal, Mr. Roddy.
Oh,
In honor of his big day,
birthday.
we are playing a song that's very special to him.
No, but those are supposed to be
But,
coming
Tigers,
back.
this song asks an important question we can all ponder. Stand by for it when the bell sounds.
Of course, because
Is that the birthday song we're used to?
Dude,
we're supposed to be bringing it back. But...
Sorry, that's good. I need the birthday song again.
Oh, God, I know. We had big
Happy birthday.
So, Angels Online, if you can like pretend there's no noise in your background right now. Did any of you get the answer to number 3?
I got 216 pi.
216 pi? Hello?
Yeah,
Yes.
Yay! You did it. So you should get 216 pi.
Yeah, I got that too.
Excellent.
I almost didn't because I misread the problem, but I realized I misread it, and then I got it.
So you see there's oil spills, there's hypothetical cubes, there's cones, and we haven't done theta related rates. Thetas. So on Wednesday or on Thursday, we're going to do related rates involving theta or angles.
There's a hot air balloon and a camera.
The best one is there's a hot air balloon going up, and there's a cyclist riding, and at the instant that the cyclist is under the hot air balloon, I forgot what the question was, but anyway, something like that, or how high up was the balloon, or something like that. Yeah. So yeah, I'm gonna have to pull a lot of those related rates. I have a really good book by Howard Anton, the bestest calculus writer in the world.
No, the best book is the bestest calculus writer.
Howard Anton's better. Howard Anton wrote the best calculus book.
Yeah, this is best on it. That means
I
it's
know.
best.
It's objectively better than all
All right, you guys, those of you who are online, you can chill out. The bell's about to ring. If you have any questions, send me an email, because I'm thoroughly inundated at this point, so one more email is not going to matter. I'm actually to the point where I'm printing the email so I don't forget to do the changes I need to do. So do that, and I hope you all have a fabulous rest of your day on this. Oh, it's a nice day to cozy up and take a nap. So take a rest from your long day of e-learning, and we'll see you on Thursday. Don't forget to check Canvas, because in a little bit I'm going to upload that document, and I will have an assignment for some extra practice.
I'm trying to have a dog that's like super dumb. But he has like, I do the best. He has like, I threw food at my dog one time and he didn't catch it. He let it hit his face and then fall to the floor, and then he ate it. It's the cutest face ever.
Caleb, you doing okay today? Because you've been extremely quiet.
I mean, I was talking at the beginning, and I was just trying to focus in the middle.
It's hard to focus in this class because Zach and Lars, they don't stop talking ever, or they're cheering. So there's a lot of.
Miss Wilson, here's some pictures of my dog.
Oh, all right. Let me put my mask on. Hold on.
Oh, put the mask on. No,
Well.
I was just gonna show you the plastic.
Oh yeah. Okay. Do that.
Here's a picture of him. Not want to take a look.
Good afternoon, Sam.
Some more pictures.
First of all, I want to thank
There he is looking for a lizard.
Yeah, they love their lizards. That face. I love their faces.
We stay focused on getting to class.
Very fat, but
time. Please stay focused on getting to class on time and being productive when you get there. Leave the first quarter of the school year. Very important for you to not fall behind. Do not want to fall behind.
I'm Miss Wilson, if you're still there.
Have a nice day, Miss Wilson.
Bye, Miss Wilson.
Goodbye.
Miss Wilson.
Miss Wilson.